Yes, it is started. First of all, I welcome my esteemed guests, Lavi sir and Harmeet ma'am, and I'm grateful, I'm thankful to you for accepting my request and invite to be on board for the wonderful session, which is going to be a wonderful session, I'm sure about that. So, first of all, I take this opportunity to introduce our eminent panelists, our chief speakers for this session. I hope my voice is absolutely clear and I'm visible too.
Yes, sir,
Yes,
it's very
sir.
clear.
Yes, yes.
Okay, thank you. So to start with, I introduce Harmeet Kaur ma'am. She is senior computer teacher at Heritage Experiential Learning School based at Gurugram, and she's an author herself. She is a teacher, mentor, and trainer, IT curriculum developer for STEM integration, and Google certified innovator, Google certified teacher, and common sense educator. And now we have Lavi sir with us. He is a data scientist at Gartner, and Gartner, we know it's the largest research and advisory firm. And he has more than 8 years of experience in AI, machine learning, deep learning, and NLP. He is a senior faculty at International School of AI and Data Science, senior faculty and content auditor for NIT Warangal and IIT Guwahati postgraduate data science program. And he has trained more than 3,000 plus industry professionals in AI and machine learning. And he has worked with and trained people from Boeing USA, Nokia, HCL, Fujitsu, and Intel Israel. So it is going to be a super excited, super engrossing session because it's a blend of an educator and a veteran educator and a veteran data scientist, industry expert. So I'm super excited to host this webinar, and once again, thank you, Lavi sir and Harmeet ma'am for accepting my request to host this webinar, and we are grateful. And now over to you, sir. Please enlighten us, broaden our perspective with on this topic, AI and ML, and with respect to education as a domain. Thank you.
Thank you, Gurpreet.
Thank you, Gurpreet sir. Lavi sir, next slide, please. Okay, I welcome on behalf of both of us to you to this particular session. So just the previous one, yeah. So just a few housekeeping rules for the session. Since there are going to be a lot of topics and I know excitement is going to go beyond, I would strongly recommend that we maintain the decorum of the presentation. We will keep our mics and cameras on switched off and mute mode for all times. We will be taking a interactive Q&A at the end of the session. Please put down your questions on paper, or you can also mention them in the chat. We would sincerely request you to not to stop the flow of the conversation while the conversation is still going on, so that everybody's queries and answers, queries and questions can be answered at the end of the session. And we would definitely expect some great feedback coming in at the end of the session, so that we can also work on our next sessions. So this is going to be a series of 2 to 3 or 4 sessions, depending upon how many times Gurpreet sir invites us. So this is like keeping in mind this particular webinar. So could you go to the next one? So this particular webinar has been, and the series of webinars have been kept in mind with all the teachers and students and educators, fellow educators in teaching in different education institutions, whether it is in different organizations or whether they are teaching in schools or colleges. That at the end of the day, today nowadays, since we are in the virtual format and it is very easy to connect with people across the globe, and I'm very excited to look at people walking in at this particular time of on and off Saturday also. So the main agenda of this particular webinar is going to be, we're going to talk about artificial intelligence and machine learning in detail. And we will also be talking about what are the different types and strands of AI. Of course, covering up all aspects of artificial intelligence and machine learning won't be possible in one particular hour. And we would be expected to go on with further more information in the forthcoming sessions. And that is the idea. We will try to, at least for today, for starters, we would try to give you an introduction to the whole working concept of artificial intelligence and machine learning. And we will really want to show you some workable examples that you as educators can also take back to your classrooms and definitely try and practice these out. And all the hoo-ha about artificial intelligence and it being something very, something being very difficult to to understand and comprehend, and trying looking for resources and books available everywhere. This is something that, you know, if you just step on this journey as an educator, it is not a difficult task. I started my journey last year, and if I can do at this age, definitely you can definitely go for it. Lavi is an expert in his field, and he's an excellent teacher. He's my teacher, so I can definitely say that, you know, if I can learn from him, definitely you can also learn from him. He's got a great big bag of knowledge, and I would definitely recommend everybody to please pen down your questions. And at the end of the session, when Gurpreet sir is going to share some attendance or feedback form with you, please make sure that you do fill in now, so that we also know what are the queries that are there for the forthcoming sessions and we can plan accordingly. All over to you, Lavi sir.
Thank you, Harmeet. Welcome all, and thanks for joining in the afternoon. Great to see you all on Saturday, like Gurpreet said. So let me just quickly jump over to the slide. So like Harmeet said, and I hope my voice is clear to all of you, loud and clear.
Yes, sir.
Yes,
Perfect.
Yes, it is clear. It is clear.
All right. So like Harmeet pointed out, this is essentially just an introduction session where we'll talk about what essentially is AI, and we'll try to understand certain terminologies which are associated with this word AI and ML. We'll try to understand and decode individually what these words mean and how they relate to each other. Because we have seen that there's a lot of hoopla around these words, and it seems to be like an esoteric information, which is like, you know, people can't really seem to get their understanding around, and that's what we'll try to understand, that how easy it is, and it's not really tough because I seem to be working in these areas, so I know certain aspects which is there and which is not there. Now moving on to first defining what artificial intelligence is in a very simple word, or in a very simple sentence. If we have to sort of talk about what AI is nothing but making computers sophisticated enough to imitate and possibly even outperform the thoughts and the actions of people. Now, if you look into the definition, one of the very important aspect is the outperformance of the thoughts and the actions of the people and other living things. Now, the idea of the AI, and we'll sort of broadly talk about this, that AI in general is, it's not like a single technology, it's not like a single algorithm which you have to learn. It's an umbrella term that we use, which is kind of a field. So artificial intelligence is a field where the goal is, and we have not yet done it. In some cases we have, and in some cases it will take another 5 to 10 years. But the goal is to essentially outperform everything that humans are good at in terms of thoughts and actions that we are doing. Now, I agree that a lot of time it also brings a feeling that If the computers are going to outperform us, then what is that we are going to do, which is a separate discussion and a talk that we can do later. But essentially the goal is to everything that we do with our perception, with our sensory skill sets, how can we leverage the same utility to these algorithms and to this whole field so that we can create new systems around it. So in a very simple term, what comprises the whole set of things that we are trying to outperform? When we talk about artificial intelligence, I've broken down them into smaller specific things that we focus on. So for example, we'll start with machine learning, where we have predictive analytics and deep learning. So if you think about it, essentially one of the components is going to be machine learning of the AI, where we focus on predicting certain things. So prediction could be anything which is in the future state. Like for example, you would want to predict that what is the temperature going to be tomorrow, or for example, how many COVID cases are we going to have in India. These are basic predictions that we are going. Now, again, if you see the bottom line of these things, you will realize that these are again outperforming what humans can do, because we could do the prediction, but we are not good at handling so much information at scale. Like all of us can give some intuition that yes, tomorrow this is how many the number of cases are going to be, but we are not good with churning the information which is sort of available all across the internet or any other medium. Then comes the speech part. The speech part is essentially where anything that we speak, anything that we do a conversation in any language, and we all know that there are thousands of languages across world. In fact, if we just take the example of India, we have such a diverse culture of different languages. Now, this is another thing which AI tends to learn and tries to mimic and outperform. And you again have seen examples of it. For example, if you see Google Translate application, that's a one very good example of AI where it learns what you are trying to say, and it also predicts what should be the translation of whatever you have spoken into another language which you are interested in. So that is another part of AI which AI part of AI which essentially we try to predict and do things around it. Then the third part is vision, where we try to recognize certain images, and we are also trying to develop vision for the machine. So humans have vision, and it's not just the humans, but many other mammals have vision, and many other living things have vision. But what we are trying to do inside AI is we are trying to develop that ancillary part of machine which can do exactly very similar to what humans can do. Now, again, this is something not new, but this is something which you have already seen in terms of CCTV cameras, in terms of mobiles that you use nowadays. For example, when you do a face unlock, that essentially is a machine vision because your mobile is capable enough to understand that it is you and it unlocks something. So that is another part of the AI which is very prominent nowadays. Along with this, we have language processing. So language processing is, again, if you think about for a moment that what is that one data which is huge in the world, specifically considering the internet, you would realize that most of the internet is text. So if something is text, then it is paramount for AI to understand and interpret the way humans do. So for example, if I were to give you a report and I were to ask you that, can you please summarize the report and transfer the knowledge? That's exactly the same process we tend to teach AI algorithms, which are specifically built to handle NLP. So there are a lot of things where we do classification, translation, data extraction. Then comes the expert systems. Expert systems are those systems which are essentially built to handle specific tasks. So you can think of it as medical systems which are built to identify cancer cells in CT scans or X-ray. These are those expert systems which may not have many other bells and whistles of AI, but they have one specific purpose and they do exactly that. Other example of expert system is your chatbots. For those of you who have seen chatbots, this is one of the very good examples that you will notice. Chatbots are also built to do something very specific. They cannot do anything other than that. Then comes the last two part, which is planning and optimization and robotics. Robotics is a very integral part of AI. It has been one of the first areas in the world of engineering which has leveraged AI from the very starting. Because if you think about robots, all the things that we have just talked about in terms of AI are part of robotics, because a robot has to do a vision part, robot has to do a speech part, robot has to do a NLP part, and they have to be expert on a certain scenario. So those are essentially components of AI. So again, as a last conclusive point about this slide is that what we talked about is that AI is an umbrella term inside which there are a lot of things which happen, and those things are noted down in the slide, which we can now think about. So we don't have to think about AI as like something which is very different, but AI has its own components which we'll sort of slowly try to understand. Now let's take an example of that. To understand essentially what we mean by AI is trying to have a vision capability or capability which is trying to outperform the thought process of a human. Now if you see on the left hand side, there's a photo of or a image of a dog, and I'm sure a lot of you might not be uh, you yourself might not be very clear whether this is a cat or a dog, and for a lot of the others it might be very obvious that this is a dog and not a cat. But you see, this is what we are essentially trying to make the algorithms understand. So most of us know that if you think about brains, we have always talked about one thing, that all brains have neurons, and these neurons are essentially the major components of our knowledge, the major components of any processing that happens, whether we are speaking, whether we are learning, all these neurons are responsible for that. And what you see on the right hand side is a very small example of a neural network, which is essentially one of the algorithms which are built inside AI. Now, this algorithm, if you think about it, is something which is mimicking exactly the biological form of neuron which we have in our brain. What it does is it basically has bunch of different units. Think of it as a computing unit. Now, these computing units are essentially trying to take the information of the image that we have given. Now, these are essentially pixels, right? So each image is nothing but a bunch of different smaller pixels. Now, if you want to know what pixels mean, just go close to your TV or a monitor or your phone. And when you go very close, like just very near to the screen, you will notice that there are small blobs of these radiating units, which are sort of, you can single them out, and you'll be able to say that, okay, this is what the pixel looks like. So that is an information. Each image has an information which then passes through the stack of neurons, and these stack of neurons then essentially learns the behavior of what we are trying to tell this algorithm, that hey, I know that in this image is a dog, so please see all that is important for a dog to be understood. And finally it sort of translates the information up the network, and finally it says that, all right, this is a dog, I need to remember this knowledge transformation, so that next time if a new photo comes, I can very easily say that this is a dog. Now, a lot of time we see such examples and we are like, oh wow, this is magical. Can it do like any other thing? Sure, it can, but what you have to also understand is that AI still is not like humans, where, for example, you were never shown millions of images of dogs and cats to start when you were a kid, for you to understand the difference between both. However, AI at this time requires this much of a data, and this is one of the very crucial difference that we need to understand. However magical we think AI is, at this point it is still at the phase where you have to push millions and thousands of data points so that it can learn that behavior and then do the prediction. So never forget this stage where unless you have those many data points, you'll not be able to do anything. In fact, later on, Harmeet will show one very good example where you'll be able to create those data sets and then feed it to the algorithms. Now, now we always keep seeing, like I said at the very starting, we always keep seeing AI, machine learning, deep learning, all these different words, and we never seem to understand that what essentially is the difference between all three of them, because they are always used in they're always used in parallel. So sometimes we use an application and we say that, okay, we need to do ML over this, or we need to use deep learning over it. So let's once and for all, let's try to understand that what is the context of each one of it and where do we use it. And this is a very common graphical format. So as I've already said, that AI in general is a umbrella term, right? So you can think of AI as a field. It's not a technology. It's bunch of different algorithms which are sitting inside and which is helping us to do certain specific things. For example, sense, reason, act, and adapt. Now, sense is basically, all the sensory information that humans process, whether it's your smelling sense, whether it's your touching sense, or looking at things, and vision sense. Reasoning is essentially if, for example, you see some weird pattern happening and you have a reason around it, which is, all right, I know why COVID cases are increasing in India because, people are being uh, very casual about their day-to-day activities. They are not being, so this is your reason around it. That is another thing that we tend to understand through machine learning and deep learning, where we throw so much data at those algorithms and we ask them back that, all right, why do you see that certain pattern is emerging? So this is, again, like I said, it's an umbrella term. It's a field inside which you have machine learning. Machine learning is essentially um, those component which helps you reason onto the data. It also works on tabular data. So what do I mean by tabular data? So anything which can sit on Microsoft Excel, or anything that can be saved in databases, these are those things which are solved through machine learning. Again, I'm sort of talking at a very high level. There are obviously examples where other data types can also be solved through machine learning. But at a very high level, this is how it segregates. So whenever you have a tabular data like Excel sheets or CSV sheets, or you have a database kind of a thing, you tend to do machine learning over this. Similarly, deep learning essentially goes with data sets where you have images, video, audio, and all the other kind of unstructured data. So, sorry. So this is essentially what, if you think about it from a very high level, the field of AI comprises of two ways of solving problems to help it do the reasoning, sensory predictions, actions, and adaptations. Is basically machine learning, which can do the tabular prediction, and the deep learning, which will help you do the image, videos, and audios. So always remember in these two differentiation that if you, for example, the dog and cat classification will go in the deep learning area, versus if you were to solve a COVID prediction problem, that what is, whether you will have COVID or not, or whether somebody will have COVID or not, will go to the machine learning, because it's a tabular data. You have rows and columns associated with this. Now let's again take a basic distinction between machine learning and deep learning. In fact, let me jump to the next slide, and there we'll sort of try to understand it more, in a much more easier way. So let's say your goal is to sort of do a facial recognition, which is that you open a camera and it has to tell you that there exists a face, and this face is, let's say, Lovey. Now, in machine learning versus deep learning, essentially the biggest difference is with the feature creation. In machine learning, what you have to essentially do is you have to take a data, you have to define the features. Now, what do I mean by features? Now, if you see this image, what I'm essentially doing is I'm explicitly mentioning to the algorithm that the circle that you see is the face in the data. The dots and the T shape that you see is the eyes and the mouth. Essentially, I have to explicitly tell the algorithm that, hey, these are all the things which are important features of a face. Now, please take this, remember this, see thousands of examples like this, so that now when I send you the new example, you should be able to figure all of these things out. So the common process of machine learning goes like data, you define the features, and then you do the prediction, which is essentially where your algorithms like SVMs, random forest, naive Bayes, these are all common names. Again, you don't have to worry too much about these names because these are algorithms which are going to come later on when we'll take more sessions. But these are those specific algorithms which are part of machine learning. Now, the whole theory changes the moment we shift from machine learning to deep learning. Because what happens in that is now you don't have to give any features. What you essentially do is you pick up an algorithm. Let's say you pick up an algorithm which is part of a deep learning world, and you just throw the data at it, and you just let it know that, hey, this data has a face, and this data has this face, and this data has this face. So all I'm trying to tell to this algorithm is that this face is Mark, and let's say I have thousands of images of Mark, and let's say I have another person whose images is also there with me. All I do is I just throw this image to this data, and it has, you can now very clearly see that it has a function of neurons, which we again relate very well to the brains, and it has this intelligence where it tries to understand each and every aspect of what this face is, and it tries to remembers it, it tries to memorize it by using certain mathematical operations, and then finally does the prediction. So this is where one of the, oops, sorry, um, this is where one of the key defining feature of both machine learning and deep learning is. And this is something you always have to remember, because you should never confuse these three terms, which is AI, machine learning, and deep learning. Each one of this has specific purpose, and you have to use them for a specific purpose. So this is what we have in terms of machine learning versus deep learning. Now let's see that in the world of machine learning, what different kind of categorization that we have, what different kinds of problems that we can typically solve. So at a high level, machine learning gets divided into supervised learning and unsupervised learning. So before I go to the unsupervised and reinforcement, let's discuss about the supervised learning. So the supervised learning is essentially that kind of a learning where you already know what you're going to predict, which is, let's say my goal is to predict what is going to be the weather tomorrow. Now I know this, and that's why we call this as supervised, because you have a supervision on what you're trying to predict. What it also means is that you already have a data from a historical point of view. So no matter what kind of problems you're trying to solve in machine learning, if you have a historical data and you already know among that historical data what is that you're trying to predict, it then comes to supervised learning. Now supervised learning in itself has two levels of categorization. One of them is classification and the other is regression. And it's very simple to understand. See, classification is the prediction of the category. For example, will I get COVID or not? Yes and no. Will I get the loan or not? Yes and no. Will my transaction be fraud or non-fraud? So these categorization, when you predict a category, which is yes, no, 1, 0, true, false, it could be 2 categories, it could be 5 categories, whatever is, whenever you do the prediction in the category format, we term it as a classification. On the other hand, if you do the prediction in a number, like in a value, for example, what is the weather tomorrow? So weather cannot be a category. Weather has to be like a number. It is going to be, let's say, 23.5 degrees Celsius, or tomorrow it's going to be 20.4 degrees Celsius. However, if you were to do a classification in the weather prediction, you might say that, all right, tomorrow will it be cold or not? Then it becomes a classification. So these are two different kinds of supervised problems that we have. Now, the most important aspect is, why do we care about these two different categorization of supervised learning? The reason you need to care about this is because the algorithms which are going to solve these problems are also going to be specific to these. So you have separate algorithms for classification, you have separate algorithms for regression. Unless you know this, you won't be able to know what is the algorithm to use to solve a certain problem. Now let's take some basic example. So we have already taken customer retention. So for example, Big Bazaar wants to know whether um, whether the person who has bought something from us this month, whether he'll be buying next month or not. So yes, no. Diagnostic I've already talked about in terms of COVID. Similarly, in regression, you can see weather forecasting is a good example. Market forecasting, so what is the value of stock that is going to be there tomorrow? So these are certain basic examples of supervised learning. Now, just the contrast of what supervised learning is comes the unsupervised learning. In that, I'm going to talk about one which is very important, which is clustering. Now, unsupervised, unlike supervised, has no supervision. You do not know what you're trying to predict. Now, let me give you a very good example of it so that it sort of makes sense to you. If you see at the very top, you have a recommendation system. So all recommendations that you see on Amazon, Flipkart, or Netflix, or any platforms that you're using, all these recommendations are unsupervised learning. Why? Because Netflix or Amazon doesn't know what they need to tell you. What they do is they analyze it on the fly and they say, all right, Lavi has bought this, this, and this. Somebody has bought this, this, and this, which is very similar to what Lavi has bought. So, all right, let me give the same recommendation to Lavi and see whether he buys it or not. So, it's not very important for Amazon to be absolutely 100% right on that. Even if I don't buy it, I'm anyway buying the main thing that I was supposed to buy. So this is what the other side of machine learning looks like, which is the recommendation system, which is very common. Again, why do we care about all these things? Because if you were to think about a problem that needs to be solved, you need to know the classification and the categorization of the problem so that you can target specific algorithms for it. And the last one is the reinforcement learning. Reinforcement learning is what happens a lot in robotics. And one of the great examples in which Harmeet will also show you at the later time is your self-driving car. So I'm sure a lot of you have already seen these amazing YouTube videos, and we have already, you might have your families and friends who use Tesla nowadays, which is essentially relying on deep learning, reinforcement learning, AI to basically drive the car on its own. Now, think about for a moment that for it to drive itself, it has to have a knowledge of so many things. It needs to know where the driving path is, so which is to say, it needs to know where the road is, it needs to know where to stop, where to drive. It doesn't have to hit humans, and so on and so forth. So all of these things sort of comes, the planning and the the optimization and the planning and all those things sort of comes inside the reinforcement learning. Now coming to the deep learning, just like we have different types of deep learning, just like we have different types of machine learning, we also have different types of deep learning. And you can very clearly see that types of deep learning are all neuron represented formats. They are genuinely not like this, but whenever we do discuss or we teach, we always represent them as networks of neurons, because this is where um, the whole idea is. Now there are a couple of very important ones. So you have convolution networks for images. Now you don't have to remember all of this, because like Harmeet said, we are going to have certain sessions later on which will talk about this. You also have GANs, which are essentially for all data types, and they will help you generate data. And similarly, you have recurrent neural network, which is essentially for text or any sequence data. Now, again, these are things which you should just know at this point, that there exist a lot of different algorithms inside deep learning as well, which are built for specific purposes. Now, all I want by the end of these slides for all of you is to take this thing back with this whole session, which is that what are these basic definitional boundaries of these topics are, what are different categorizations, and why are they important. That's all. If you don't remember it, it's fine. You can go ahead and sort of learn more about it. Now, the final one, which is data science, because we have talked about AI, we have talked about DL, we have talked about ML, but then there is something called as data science. And we are now again confused because there are 4 different words to define the same thing. Now let's understand what essentially is data science. So one of the important things to understand about data science is nothing but a process. It's not a technology, it's not an algorithm, it's not what we have discussed about MLDL in general. It's a process. It's a process. It's like a scientific process, and that's why you see it has so many components that are part of it. One which we have just talked about, machine learning and AI. But at the same time, it has components of maths and statistics. It has components of subject matter, which is essentially to say that whatever you're trying to solve a problem, the domain is very important. So you need to know the domain of the problem that you're trying to solve. And then obviously the coding part. Now, the reason I wanted to put this slide is very important, because what happens is a lot of time I've noticed that when people teach AI, they focus heavily on only one part of it, which is the code part. So most of the people think that AI is just about code, and which is very wrong. See, when we are trying to teach students, we have to be very careful, because they either might have an inflection towards code, or they might be very okay with it, But either way, we should teach them the overall process of what the data science is, which includes AI and machine learning. Along with this, that also includes mathematics, and a very elementary mathematics which they have already studied or they are studying in the 11th and 12th. So AI could be very important for them, because for the first time they will see all the mathematical concepts that they are studying in 11th and 12th and 9th and 10th to be then used for real world use cases, which is again the good ones which they see every day. So it's very important that we need to understand that AI is not just code. AI is also maths. AI is also machine learning algorithms. It's also research. It's also domain. So it's the accumulation of all those things together. So we always need to make sure that we understand and we communicate this very well to the students. Now, before I end and hand it over to Harmeet, let me quickly show you one very beautiful example. I hope you can see. I hope you can see the screen. Visual introduction to machine learning. Let me know over the chat.
Yes, it's visible.
Okay, perfect. Now, this is one of the very beautiful, beautiful website which sort of walks through the whole idea of machine learning in a very visual format. And this is a must shared resource with students, because that is when they'll be able to understand that the things are so beautiful, right? So for example, let's take a use case. So what we'll do is we'll take a use case of doing a classification whether a home is in San Francisco, New York. So imagine that there's a data of certain buildings and certain properties of buildings. And the goal of the algorithm is to predict whether this building belongs to San Francisco or it belongs to New York. So you can see that the green one is San Francisco and the blue one is New York. And you have a certain property, which is the height, 744.8 feet, versus the 239 feet in the New York. Now, as we see, we can keep on adding a nuance to the data. So the moment I flip I flip the view of the data, we can now see by adding one more, which is the square foot area, which is the coverage of the coverage of the area. You can now see very clearly that we can start seeing the patterns. For example, if you notice on the at the very high, you can see that this is all the part where between $239 per square feet till 1700 per square feet. Oh, is it? Is the text visible? Not able to see the visual
No, no,
graphics?
we can. We
Oh, you
can.
can.
We can.
Okay.
Yeah.
So what you can see is that it's not something magical that the algorithms are going to see. It's exactly the same thing that you see on this graph, which is again a way to represent your data, is that algorithms are understanding that between a certain range, if you see the green shaded area, this is the range where it is 100% confident that if I get any data point in this range, I'm going to predict this to be a San Francisco building. Whereas if I get anything in the blue shaded, I will predict this as a New York building. However, sure, if you see the white shaded, which is not the shaded region, you can see that there's a lot of confusion which is there. And this is what algorithms try to nullify, and they try to do more complex analysis. But overall, this is exactly what is happening in the backend. So the things that we are calling magical is not magical. They are essentially just like this visual analysis that we are doing on the data. So again, this is a very simple representation of it, but it's very important for students to understand that it's not that hard if you sort of try to understand. Now let's try to complicate this problem by introducing many more features of the flat. For example, the elevation of the flat, the year build, the bathrooms, how many bedrooms do we have, the prices, the square feet. Now again, if you notice, what is happening is with respect to, if you pick any one, so for example, if you pick the bathroom one, you can see a visual pattern that depending on the number of bathrooms, there is a difference between San Francisco buildings versus the New York. And this is what, the visual analysis and the visual prediction we are trying to do. Now, let me show you one last thing into this, and then I'll stop, which is what essentially models do. So there's a very famous model. There's a very famous model called decision tree inside AI. What they essentially do is when you pass a data to this model, it tends to create those different spaces, and it then tries to memorize those spaces. So the next time when you see a data, it will automatically give you the prediction of it. So how does that happen? It's very simple. So for example, if the elevation is this, if the elevation goes, think of it as like a filter. So if the elevation is greater than this, it will fall onto one kind of classification. If the elevation is on the left hand side, it will fall onto the left hand side of the classification. So you can see that it's a very beautiful tree that is being formed, where each rule defines a specific blue or green. Blue and green means New York and San Francisco. So you can very clearly see that how each rule is sort of giving us some kind of a prediction, and this is exactly what models are trying to understand. And see, this is very important for us to get, because this is where it takes the magical part and brings the mathematical and logical part of AI. So you can now see that how these things are going in that tree. And if you notice, these trees, these strands are nothing but one rule. So if you see, if the year built is less than 2000, there is a chance that it will go into the New York building. You can see that there's a prominent blue line. So the more data I flow into this, you can very clearly see that how more and more data I'm flowing into it, there's a probability which is shifting both in terms of blue and green. And this is what the whole idea of AI is. Now let's see this again, how beautifully they have presented that as the data starts flowing from the top, so we can imagine it to be like a waterfall, and these are those rules that the data has, and it is exploiting that rules to remember this for the future data points. And this is how it learns what is a building which is a San Francisco building and what is a building which is a um, New York building. So overall, this is how a lot of things work. This is a very simple classification problem, but this is the base of how most of the things in AI work. Now on this point, I will stop. I will give the session back to Harmeet, and she can take it forward. Thank you.
Thank you, Lavi, with the presentation. You can stop sharing your screen.
Just it.
Okay. So thank you everyone so far being so patient and being a participant to the conversations that have been going on. And I'm 100% sure that whatever you are learning so far is definitely going to be very helpful when you are sitting down with your students in your classrooms at any age bracket, and would be able to explain the whole concepts. Because as sir said that it is just not about the coding, it's just not about learning Python, it's just not about learning about object detection or NLP. It is just about the whole thing as a single package. So the whole umbrella term of artificial intelligence is covering all this, all is summation of all these concepts in together. So that is what I'm going to take over from where Lavi has stopped right now. So we are going to talk about, so the last that conversation that had happened was about data. Okay, so what is data? So data is basically just characteristics or informations that we have collected through observation. Okay, and as data science definition was given by sir also, so it is basically just an interdisciplinary field that uses different as I would say scientific methods, processes, algorithms and systems to extract knowledge and insights from many structured and unstructured formats of data. So it is basically related to data mining, machine learning and big data. Now, it is very essential that we are talking about learning about data analytics, because data analytics is the science of analyzing this data to make conclusions about that particular information. Now, there are many techniques and processes which have been automated so that the algorithms can work over that raw data and we can consume it as humans in our own understandable way. So, the person who's actually designing this, the person that we call, is not just an artificial intelligence engineer. There are so many roles and supervisions that come into this particular field. So basically a person who would be able to leverage existing sources and create the new ones in order to extract this information for actionable insights, that is very important. So as as a data scientist, I would definitely would want to have the business domain expertise. I must have the effective communication, and the results interpretation should be such which utilize all relevant statistical techniques and programming languages. The insights that are covered, they help us drive business decisions and take actions intended to achieve business goals. Now, as explained by Lavisa earlier about the importance of data and why it is important, let me share a web resource with you, which is called as Social Alert. Okay, now Social Alert is basically it's a web resource which tracks social media, post hashtags, and social accounts. Now, this tool helps me measure metrics, including various impressions, sentiments, and viral content for any particular hashtag or account. It is very important for me to understand and explore data in meaningful ways, because data in itself is only just facts and figures. Okay, so if I were to show you this particular site in live, let me just change my tab. If you can see this particular link, so if I were to give a hashtag for any particular, it's very easy for me to track any hashtag across different social media accounts and portals. So it gives me, so understanding data and how exactly, it is going to take a second to actually just give me the predominant presence of that particular data. So if example I'm looking for hashtag COVID, so when we are looking at that particular information, with data mining, I can extract this data in the form of an Excel or any CSV or a database file, and then I can do my analysis on it. You can very well see the tweets and impressions, the influences that automatically have been utilized. So that many number of, this is live data right now. So if this is a hashtag, how many tweets have been done, how many reaches have been done. So the analysis over here gives you a clear impression of what exactly is giving us this live data. So which are the people who are the top influencers and active socialists. So this particular, it is again, as I would say, it is very important to explore data, because in itself it's just merely facts and figures. This data analysis is helping me organize and interpret structures and presents the data in such a useful information format that provides me the context of data. So this is particular a site that you can probably use in your classes to show the students how the data analysis can be tracked. So this is all about data. Another important resource that I would want to share with you that I basically utilize in my class is the data viz catalog. Now, understanding about data, presenting of data, and then what are we going to infer from it are two or three separate things. So if you look at this particular site, in this particular site example also, you will see there are a lot of ways of representing the same data. As an example, the popular one that we generally pick up in our classes is generally a bar chart. But now with a bar chart, as also Lavi sir said, that it's just not about understanding, it's just not about the coding, it's also about understanding how the data is presentable. But again, with teaching computer science and AI inside our classrooms, it is also important for us to look at the coding part also. So just not about understanding what that particular chart is all about, what are the different types of charts, and over here, the biggest beauty about Python as a coding language is that you do not have to actually even remember most of the things. As a data scientist, as a person who's making use of all these, so I have the option of just exploring the same resource over here. So this is what I had done. I just picked up which is the tool I'm making use for generating it, since we are talking about Python. So we can just pick it up, and if any of these particular graphs I want to use in for my particular data set, see, it generates it tells you what kind of legends are being used, what is the value on the x and y axis, and what is the code which is available to you. So this helps you understand what is the important part. The important part is to understand about the business domain, about the problem, the data which is existing over there, and how we can actually make use of data and represent it in the form of a graph. Visualization. So as far as I can understand, so data visualization is the graphical representation and information of this data. And by using these such visual elements like charts and graphs and maps, such tools are helping me provide ways to see and understand the trends and patterns in data. So it is very important for me to understand the importance of data representation and how the students can actually visualize the data that they are looking in the form of text. Let me show you one more dashboard. So let me just show you one more dashboard. So if you look at this particular dashboard, this dashboard is extracting data directly from the live status right now. So it is very important that I should be able to understand the importance of data representation or the dashboard, because it helps me understand the underlying insights and it is helping me take constructive workable decisions. So if I'm in the position of the government, I am at that particular point of time, I have to decide whether the schools remain open or they remain closed, what is the percentage. So we are actually going through the newspapers and different Facebook posts and Twitter posts nowadays to figure out, are the schools going to open? Is there a problem with the health care professionals, which is where they are facing the problem? Where all those areas where I can pick up the plasma for some of my near and dear ones. So such kind of information when is presented in a format which helps me figure out. So let me just pick up another country at this particular point of time to show you. So if I just pick up, let's say, Australia. So such a dashboard, it is, and looking at this representation, you would feel that this is taken, so you will see this, the numbers have changed. See, the numbers have changed. It takes a minute to filter it out, but this is what it is giving to me. So if such information is available to me in live form, so this is hosted online, and that is why we are getting the information from the data source directly. So I will help you understand how we can actually go ahead and design such kind of a such kind of a dashboard also. So this such a dashboard, it's an operational dashboard. It is providing me a comprehensive snapshot of the performance of data, which means that we can incorporate a large amount of details in this for clear insights. And since the analytical dashboards, as sir has also said, they generally use data from the past to identify trends that can influence our future decision making. Let me just go back to my presentation. So we have talked about these. Just give me a second. Let me just go back there. Okay. So this was a snapshot of the dashboard that I showed to you. Another important strand of artificial intelligence is computer vision. Okay, so object detection is basically a computer vision technique that object detection is a computer vision technique that allows me to identify and locate objects in an image or a video. So hence, with the this kind of identification and localization, object detection can be used to count objects in a scene and determine and track their precise locations, and all the while accurately labeling them also. So for example, there's an image that contains two cats and a person. So object detection allows me to at once classify the types of things that are found while also locating the instances of that particular item, that particular instance of them within the image. Okay, so everybody has looked at the example of quick draw when we have done this with our students inside the classroom, right? Where quick draw, now everybody has decided that when you work with quick draw, it's a Google experiment. It's an online game developed by Google that challenges players to draw a picture of an object, and then it uses a neural network artificial intelligence to guess what these drawings represent. So basically what is happening at the back end is that the AI is learning from each drawing, increasing its ability to guess correctly in the future. So if I were to just show you the database for a particular image, so if I'm drawing and doodling for something, if I just pick up at any particular image, so at any point of instance of time, if somebody has, let's say, drawn a butterfly, so it looks like a game to the students, but this many number of people have actually drawn a butterfly. So every single time a butterfly, so the example that Lavi was giving to you initially about the face detection, this is the same example that is resonating with the same feature. So you pick up at any particular, so if a new butterfly image was given, it was actually compared at the back end with all these images in the format, and then the final network, and then it was finally decided when it said, oh, if you have played this game, you will understand what I'm talking about. So when you start drawing, so if over here, if I'm just going to start drawing and say, if I say draw a stethoscope, so if I'm just saying I'm drawing a stethoscope, so what is it trying to do? It's trying to just actually make a, so it tells that it is a stethoscope. How was it able to tell that? It was able to tell that only because there have been instances where people have been making stethoscope and it has been able to speak it out. And just imagine how fast it has happened. So the comparison of the features, that is, so a stethoscope, so it is automatically trying to figure out this is a feature, second feature, third feature. Yes, now I'm able to figure it out, filter it out that this is finally a stethoscope. Looking at another example, looking at another example. So this is something that we have already talked about. Okay, so now sir was also talking about an example.
To interrupt you in between, somehow your screen is not visible to the participant. Someone has clicked the present now button by mistake. I would request you to please
Okay,
reshare it. Stop sharing, stop share, and then reshare.
can you see my screen now?
Yes, it is.
Can you see my screen now? I'll just go back to my presentation. Can you see it now? Sir, is the screen presentation visible to everybody?
Yes, ma'am. Yes.
Yes,
Okay,
ma'am.
thank
Yes.
you.
Now it is visible.
Okay, so let me just show you one small video of actually. So when what happens when so let me just share this small video with you here. So if you see, basically what is a self-driving car doing? So now let us look at this video, and it is actually doing the unthinkable right now. So such driverless cars have detailed three-dimensional maps that highlight information such as, road profiles, curbs, sidewalks, lane markers, crosswalks, traffic lights, and other road features. The sensors and the software, they scan constantly for objects around the vehicle, like, the pedestrians, the vehicles, road work, obstructions, and continuously read traffic controls from traffic light color and railroad crossing gates for temp or sometimes there are temporary stop signs also. So the software predicts, let me show you one more. Wait a second. Where is the other one? Here. So basically when it starts reading that, it understands, the software predicts the movements of everything around it based on their speed and trajectory. Okay, it understands that a vehicle will definitely move very different from the way a cyclist is going to move, right? And then the software decides using that information to predict the many possible paths that other road users may take. Hence, based on all of this information, the car software determines the exact trajectory, speed, lane, and the steering measures it needs to progress along the route safely. So you can see over here it has automatically stopped it had detected that another vehicle has come over here. So that is how it was actually working. So going back to my presentation again. Wait a second. Okay. So I also want to show you that there are certain. Wait a second. Where is that? Here. So there are certain just like we have. So there are certain data sets which are available online for us also to go ahead and look at the features which are available different. The road estimation evaluation. So these are the generic data sets that many companies are now trying to come up with who are into this, just like Waymo, which is the self-driving car. So they pick up these data sets and the information that is available to them, and then they try to give this kind of information to the algorithms also. Lavi, I think I have covered this particular part clearly. Is it anything that you would want to add up over here for this?
No, I think everything is wonderfully covered. Can you go up just to give a context of in the same link,
Which
in the
one?
same the data link that you have opened?
So I should share the data link.
Yeah, yeah.
Okay, give me a second. Wait, which is the tab there? Here.
So if you go at the very top, right? So this is what I said that at the very starting that the AI algorithms are not doing this out of no learning. You have to feed it a data initially. So all the wonderful videos that you have seen has gone through the phase of training where these data that you currently see, which a lot of big universities and companies have created by their own, and they have tagged everything. So they have tagged the roads and they have tagged the vehicles. So by tagging it means that you're basically providing the information to the model. So this is where I said that this is what we call as supervised learning. You need to first
Hmm.
supervise the algorithm to understand that, hey, this is a road. No matter where you see something like this, you're always supposed to tag it as a road. So this link sort of helps you understand that um, whenever you send it to an algorithm. So if you see this video, all things which are tagged by the algorithms are done because it has seen so much of a data beforehand.
Hmm. Thank you for pitching in. Okay, so I'll just go to the next strand, which is the NLP. Now, NLP is basically a part of AI, as we all are, attuned to understanding. When we talk about Alexa, we talk about our Google assistants, we talk about Siri. That this is all about NLP. But basically, what is NLP? NLP is that part of AI that studies how machines interact with human language. So at this point of time, it is taking into account the now this particular time we are not having images or numbers as the data source points. We are having the sound as the data source point, right? So if I have recognized myself as a person who talks to the Alexa every day, I might not be speaking in the same pitch and tone with my students or with my Google Home. So it keeps on recording those features of my voice, and at one particular point of time is able to realize that this is the person. So whichever tone that I'm speaking in, louder or at a lower rate or with a different tone, it is recognizing me that this is the person that is one who's asking for any particular operation to happen. So just like earlier, you had earlier that Lavi had explained to you about neural networks. So in this particular infographic also, you will see that how are neural networks recognizing whether it's a dog in the picture. So basically, it is all about making different classes or which are being passed, the features which are being passed to the input layers over here. So whether it is picking up the nose, the paws, the tail, and then trying to figure it out and filter it out that whether it is a dog or whether it is a wolf. So a very popular example that most of the times that we are making use of in our classrooms is that of a teachable machine. I will not take much time over here with a teachable machine since most of us have already done that example in our classrooms. So basically, just to tell you that this is what exactly the neural network, when we are talking about, is giving over here. So if I've given it 50 images of cats and 50 images of dogs, it's been trained to figure out the different features inside these images and then trying to predict out that whether it is a cat or whether it is a dog. I'm sorry, I don't have a webcam. Otherwise, I would have actually shown you that when you run an audio project also. Oh, wait, I have a screenshot of the audio project. Wait. So when you have an audio project, over here you will see that it is having the audio samples of a clap or a whistle, and it's also having that of the background noise, my voice. So whenever there is a whistle, if I've trained my model with the different audio and video audio samples over here, it has classified it with the features which are pertinent to that particular class, and that is how it is able to figure out when a whistle is blown at this for this particular model to recognize that yes, 100% this is a audio which recognizes that of a whistle. Going forward, the last section of our presentation today is that of a workable example. Now, the challenge is that whenever we start talking about artificial intelligence, whenever we talk about attending any workshop or this thing, every single time we end up being confused. What kind of a project is it that we should be doing for our senior students or for our 9th and 10th graders, or for that matter, just to just to see whether if what we have learned and heard is actually making any sense. So just like, let me just show you a workable model, and then you can actually figure out what exactly it is. So I'm just going to introduce to you one module which is called as a Streamlit module, right? So a Streamlit module is a very powerful way of representing your format with very less amount of code. Now, if you look at Python as a language, and why is Python as a language very popular? Because it is having so many modules available online to you, which you can make use of for deploying your models. And it is and beauty of this particular language is that you do not even have to remember everything over here. Let me just showcase one small example to you here. So this is the site that I'm talking about. So if you would just go and even if you just look at a particular example, if you look at this example, if you're looking at the I'll show you this also simultaneously. Let me just show you a workable example over here. So if you look at this particular example, we talk about Lavia talked about to you about a credit card fraud detection system, which was a classification problem. Okay, so now if we can teach our students how to make a clean project like this, and you will be surprised at what less the amount of code is basically required to do this. Yes, it is for a grade 11th or a 12th student that you can talk about, but yes, at this particular point of time, if you're looking at creating and deploying a smaller problem statement, then you can easily understand it. So if you would see, the main important part over here is, understanding what we talk about the AI project cycle. And again, we have talked about the CRISP DM model inside our classrooms, where we are talking about data exploration, data acquisition, making sure it is coming from reliable resources, then visualizing it, then cleaning it, wrangling it, and then visualizing it, and then finally creating a model and evaluating whether the model is making the correct prediction or not. Just to showcase a very small example, so if we are having a clear cut understanding about what my data set is all about. So if I'm going to show you the data set, so for example, this is a data set which is given to you by a bank. So the data set, everybody can pick up a data set from so many web resources available online. There is Kaggle, there is Data World, there is data.gov.in. There are unaccountable amount of number of data sets which are available to you online. So just to see whether the credit card fraud has happened or not, as an example, if I have a lot of data which is containing information for, the number, the merchant, the category, whatever information that we have. Now there could be a lot of, does the job of a person actually qualify to be a feature that, a credit card fraud should happen? What is more important? Is the gender of the person, the name of the person important for predicting a fraud? No. So we need to clean up our data. We need to drop those. So understanding the data set is very important. First and foremost, understanding what the problem is, what is the data set and what is the problem with it. That is very important. So if I know what my data set is and what kind of a problem can occur with this kind of a data set, that is very important for me to understand first of all, even before I decide that, I want to do a prediction whether the fraud transaction has happened or not. So if you look at it, there are, in this particular data set, there are around 1 lakh and nearly 35,000 records which are over there. And there are certain features which can definitely be kicked out. So if I just look at preparing my data, okay, so assuming we have done all the cleaning and wrangling and everything, now I have prepared my data and dropped all those data sets that I do not want to. So there are different steps that I have used. Okay, so let me just show you the database, the set after it. So just looking at the data set right now, you will see that all the essential features which were required for predicting whether the data set, so you will see I have encoded all my data set, looking at what is the correlation between those features. Irrespective, so just like, let me give you an example. Most of us go for board paper checking, right? We never know that when we are trying to check a paper of a particular student, we don't know the name of the student. So what is important for us? What the important feature for us is to know that this is the roll number and this is the paper and the question marking sheet that we have, and we check the papers accordingly. So we are actually hiding it behind a particular field. Similarly, over here we have encoded it in such a way that what is essential is only available to us for doing this. So there are other ways of representing the data, of looking at creating a profiling report. But what exactly I am trying to show you over here is the data analytics. So if, like what sir had also explained to you about the classification algorithms, so this is a supervised learning where we are talking about. So if I'm picking up, let's say, a random forest, right? And I'm trying to figure out if I want to run a random forest algorithm on my data set. Apologies for it being a little delayed because it's a very huge data set with 1,35,000 records over here. So it takes a little bit of a time to just create the report. Okay, I'll just remove the pandas profiling report. And if I run the model for my only random forest now, so when I apply this particular algorithm, what is it that it is trying to predict? How many transactions were actually fraud and how many transactions were actually not fraud? Give me a second. So there it is. So it is giving me an accuracy. This particular algorithm is giving me an accuracy of 99.8%. So you can see how many were actually the correct ones, the valid ones, which were actually correct and which were not fraudulent. So this is about the classifier. It is telling you. I can also compare my models to figure out. So from a student perspective, if a child can actually visualize the way he understands the data. So if I am, for example, I'm trying to say that I want to travel to my school, what is, so if you look at your Google map, in the Google Maps also, you have the option of selecting, when you're picking up the distance between 2 points, it gives you what is the total time that you're going to take. If you start walking, you take the bus. So when the data is represented to you in the form of digitized, in the form of a digital pattern, it is easier for you to understand and comprehend, which is the map which is completely clear to you. And in fact, if you look at the code, wait a second, I'll just stop sharing and share you the screen once again for you to show that even the code is not that big. It's very small. Your entire screen. Wait a second. Here. So if I show you the code also, it's not exactly. So if you just miss out on the text that was written, this is just a simple text. Just look at the amount of colored lines that is in the blue or green. The brown one is only the text that you had seen on the screen. How much amount of code is there? Barely anything. Barely anything that is there. So all that you see in brown is just the text that was displayed on the screen, nothing more than that. So it is a simple set of, it's a very simple way of, going back to the basics. So if I were to show you, wait a second, give me a second, please. Here, let me just deploy this once again. Let me just, here, take a second. If I just show you the very basic, this will definitely give you the idea of what I'm trying to explain to you. So if you look at this, if you look at the very basic demo of Streamlit, if I pick up an animation, so you can see, so just like I have the option of, you can see, and the progress bar also, how the separation, so I can drag and drop. So this is a very simple module that you can, use for your grade 9, 10th and 11, 12 students for creating a project and deploying the way they want to deploy their model. Look at that. If I pick up mapping data, so just to show, so just look at kitna code hai. Hardly any, itna sa code, and look at what we are going to create out of it. See, I can actually see the same data. I can map the geospatial data in a format in which I'm having live data picked up for it. I picked up, if I'm looking at plotting a demo, I can also see, I can also save this as a picture PNG. The same thing that we are teaching our students. And how much amount of code was there? Only this. So it's up to us as teachers, that what is it that we want to teach our students and how we want to go ahead and explain what artificial intelligence is. Because machine learning is definitely not very difficult. It's going to be our own mindset that we have to work on. And that is the same thing that we have to propagate to our students also. I hope that we have been able to help you out with the learning of the basic concepts. And if you have any questions, we have also shared our LinkedIn profiles with you. You can connect with us there. And of course, as discussed with Gurpreet sir